I am Dr. G. G. Ratnam, working as Assistant Professor in the Department of Food Technology, Hindustan College of Engineering and Technology, Coimbatore. I welcome you all for the dairy engineering course. As we know that, so dairy processing sector is one of the important processing sector in the food processing field. So the dairy processing is very important to the food as the shelf life of the product is very less. So we have to give some processing inputs to maintain the shelf life of the product and to improve the acceptability of the product as well as the quality of the product. So India is the largest producer of the milk and also the consumer of the milk in worldwide, and India has a very big contribution towards to the milk processing sector in the worldwide. So today's class we are going to see an important topic in the dairy engineering course, so that is the pasteurization. So about the pasteurization and its principles, objectives and different types and methods of pasteurization, and also its application in the food, and also the effect of pasteurization in the foods. So what will happen if we are applying the pasteurization technique, and what will be the result, and what will be the quality and also the nutritional changes that takes place in the end product after the application of the pasteurization. So before going to the pasteurization, we should ensure that where how the raw milk which is converted into an end product, and what are the processing steps which is available in the conversion of the raw milk into an end product as well as a value added product as a byproduct, etc. So coming towards to the so we have a different kinds of milking animals. We can obtain the milk from the uh, buffalo, sheep, goat, and also other kind of animals, even human. So the different milk products have its own the composition, nutritional composition as well as the composition. So the majority of the milk products it contains moreoverly the moisture content as a major percentage. So it has a 80 to 85 percentage moisture, and the total solid not fat we call it as a SNF 8.5 percentage, and the fat percent which is depends on the milking animal. For example, if it is a cow, the fat percentage may vary from 3 to 3.5, and if it is a buffalo, the fat percentage varies from 5 to 5.5. And we are going to for a standardization of the milk. So standardization in the sense, as per the regulations which is given by the FSSAI, the standard milk should contain a SNF of, that is the solid not fat of 8.5 percentage and a fat of 4.5 percentage. So we are going for a standardization process for that. So the nutritional composition of the milking animals, it is depends upon the feed which they are taking in the cattle farms. So the cattle farms we are giving some sort of the wheat brands and also the oil cakes and some green fodders to enhance the nutritional composition of the milk as well as the color of the carotenoid pigments and also the pigments which is responsible for the color of the milk. And after that it is transported towards to the local vendors as well as the societies and collection centers, and from that the collection centers the milk is transported to the reefer vans, that is the refrigerator vans or a normal van, normal containers or tanker lorries, where the milk is transported towards to the industries or the government bodies. So if it is a reefer vans, the reefer vans means the name itself indicates the refrigerator vans. It contains a temperature condition and RH condition of more than 95 percentage relative humidity and 4 to 6 degrees Celsius, the temperature inside the tankers, reefer vans, where the milk is transported towards the industry directly from the collection centers. So the reason is the raw milk has a shelf life of 4 to 6 hours. If you are transporting towards the industry that is far away from the collection centers, for example, if it is taking 8 hours to reach the industry, in the sense if it is not a refrigerated van, so they are taking the milk towards to a nearby chilling center that is also governed by the private industry or the government bodies. So the milk is transported, if it is a reefer van, it is directly transported towards to the industry, and if it is a normal container or tanker lorries, it is transported towards the chilling centers, where the milk is maintained at 4 degrees Celsius in the chilling centers, and then it is transported towards to the dairy industries. And dairy industries, they are converting the raw milk. Initially they store the milk and they convert the raw milk into a different products like the milk, normal milk, skim milk, removal of fat, and toned milk, double toned milk based on the percentage of fat, and milk powders, the value added products, cheese, butter, ghee, and different kinds of value-added milks, flavored milks, etc. And it is packaged in a proper manner, and it is stored once again in a refrigerator condition. It is further processed and it is transported towards to the market and it reaches the consumer. So this is the flow chart, which is the milk gets processed and how it reaches to the consumer. And this is the dairy value chain of that is present in India. So dairy value chain, as I mentioned, in the mid of 1970s to 1990s, there is a scarcity of the milk towards to the urban peoples. The rural people, they are getting the milk, but the urban people, they do not receive the milk because of the various transportations and improper areas where the milk cannot be transported. So likewise. So Dr. Verghese Kurian, he is the man is responsible for the white revolution that takes place in India during the 1970s to 1980s, and he is the person who brought the white revolution. He fulfilled the needs of both the urban people and rural people by creating a value chain, that is a dairy value chain. And he makes a chain that can, once the milk is milked from the farmers, it is transported towards to the local vendors or the chilling units, and it is directly transported towards to the dairy plant where it is gets into a product and it reaches the consumers in both the urban and the rural people, where they are get all kinds of milk products. So that is the white revolution. That is who is the man is the Dr. Verghese Kurian. And this is the, as I told, the milk collection, about the milk collection. So the farmers, they give the milk towards the vendors or VMC centers, collection centers, and sub centers, that is a chilling unit, and it is transported towards to the factory and where the processing of the milk takes place. So this is the milk packaging in the production side. So this is the processing usually that takes place. Reception, where the milk is stored at a 4 degrees Celsius, and after that, that is the cooling. It is stored at a 4 degrees Celsius, and after that, clarification or preheating. So clarification or preheating in the sense, removal of the suspended solid particles or the removal of the non-soluble solid particles that is present in the milk, that is a clarification process. And after that, preheating. So you are going for a pasteurization process. In pasteurizations, you need to heat the milk from towards 63 degrees Celsius or 72 degrees Celsius, that is the pasteurization temperature, where you are, so the product which is coming, incoming product, which have a temperature of 4 degrees Celsius. So for that purpose, you are taking the milk towards a preheating chamber where they heat the milk from 4 degrees Celsius towards to the 40 degrees Celsius. And standardization, as I told, standardization, the as per the regulations, as per the laws from the FSSAI, the standard milk which contains 8.5% solid not fat and 4.5% fat. So for that purpose, you are adding one or more constituents. For example, if it is a cow milk, it has a fat percentage of 3.5. So you are adding one or more constituents towards to the milk, and you are enhancing the fat percentage to 4.5 percentage. So that is called the standardization process. And after that, you are going for a pasteurization process, as I mentioned. So today we are going to discuss about this pasteurization process specifically, and further processing like the homogenization process and the finished product, packaging, and storage or distribution. In processing, we can get different kinds of products. So pasteurization, you are heating the milk, you are destroying the microorganisms, you are heating the milk in an acceptability manner, and after that, it can be, the processing involves, it can, that is the homogenization process, that is distribution of the fat globules in a uniform manner inside the milk, and then you can convert the milk into a different products, as I told, the skim milk, milk powder, butter, ghee, cheese, depends on the needs of the consumer. And coming towards to the pasteurization, so pasteurization is a relatively mild heat treatment in which food is heated to below 100 degrees Celsius. So pasteurization is a process which destroys all the microorganisms that is present in the milk. So it is a thermal preservation technique. So one of the thermal preservation technique that made the milk towards to enhance the shelf life or maintain the shelf life of the product. So the pasteurization process that inhibits the enzymes that is present inside the milk, and also the enzymes which is responsible for the enzymes catalyze the spoilage mechanism. So pasteurization inhibits the enzymes and also the microorganisms that is present in the milk. So we have a target microorganism that is present in the milk. That target microorganisms can be destroyed by using the pasteurization process. So before going for a pasteurization process, you should know about the acidity of the foods. That is, there are three types. One is low acid foods, medium acid foods, and high acid foods. So milk comes under the category of low acid food. So it has a pH of 6.5 to 6.7. So it is nearly towards to the neutral. So the pH of the milk that decides the shelf life of the milk. So the pH, if it is nearly towards the neutral, so it can be considered as a highly perishable product, and the shelf life of the product may be maximum 1 day. So, and if it is a medium acid food have a pH range of 2.7 to 4.5, and it may be considered as an intermediate perishable foods, and the shelf life may be 7 days or between maximum of 7 to 15 days. And coming towards the high acid food, so high acid food usually what they do, the pH range is less than 2.7. So it can be considered as the example is the bottled pickles. So the shelf life may be 6 months to 1 year. It depends on the conditions which we are storing. So milk comes under the category of a perishable product because it consists of a more amount of moisture content. So the pasteurization technique, which inhibits the enzymes as well as the microorganisms, it will maintain the shelf life of the milk. It will increase the shelf life from 1 day to 3 day and 3 day to 7 day. It depends upon the processing condition, that is the time and temperature combination which we are using here. So after pasteurization, we are so before going that, the inventor of pasteurization is the Louis Pasteur. So he identified the pasteurization technique for the wine preparation. So to destroy all the pathogenic microorganisms, he identified the pasteurization for the wine preparation. So he identified two time and temperature combinations, that is 63 degrees Celsius for 30 minutes and 72 degrees Celsius for 15 seconds. So this is the we have a three types of pasteurization method. So one is the LT-LT and another one is the HT-ST, and the last one is the UST. So before going that, we should have our objective. So to render milk safe for the human consumption by destruction of all the pathogenic microorganisms, to improve the keeping quality of the milk. So with less or minimal quality changes or nutritional changes that is present in the milk, by heating that, destroying the target microorganism, that is the Coxiella burnetii. As I told, the target microorganism that is present in the milk is Coxiella burnetii and Mycobacterium tuberculosis. So by pasteurization technique, we are destroying these microorganisms, both Coxiella burnetii and Mycobacterium tuberculosis, and formulation of standards. So bacterial destruction, that is the target microorganisms, and pasteurization helps to in cream line reduction, that is less changes to cream volume during heating, and also the phosphatase inactivation test. So this phosphatase inactivation test ensures that we have done a correct pasteurization method towards the preservation of the milk. For example, if you are heating the milk at 72 degrees Celsius for 15 seconds, it should kill all the microorganisms present in the milk. If it does not kill, and if you are getting a fouling smell or a off flavor, in the sense you have not done an exact pasteurization method. So if it is like, then the phosphatase inactivation test shows a positive result, that indicates that you have not done a complete pasteurization technique. If it shows negative, it shows that you have done a complete pasteurization technique for the destruction of the microorganisms. And this is the theory. So pasteurization usually uses the sensible heat. So from 0 degrees Celsius to 99 degrees Celsius, we can measure the amount of heat required to rise the temperature from 0 to 99 degrees Celsius by using the formula Q equal to mc the theta A minus theta B. That is the temperature difference between, as I told, from 0 towards to the 99 degrees Celsius. The initial temperature of the milk, for example 4 degrees Celsius, towards you are heating to a 72 degrees Celsius. And as I told, this is the different methods of pasteurization, LTH or LTLT. So that is low temperature and longer time duration. So 63 degrees Celsius for 30 minutes, and before cool to 7 degrees Celsius, and HTST. So 71.5 degrees Celsius or 72 degrees Celsius for 15 seconds before cool to 10 degrees Celsius. And third method is ultra high temperature. We usually call this ultra high temperature as one of the sterilization technique. So 138 degrees Celsius for at least 2 seconds, and extreme pasteurization kill all microorganisms that is present and keeping milk in a closed sterile container at room temperature. So this is the method. So the industry people, they are using the HTST as a optimum pasteurization technique for the preservation of the milk. The reason is the LTLT, you are treating the milk for 60 degrees Celsius for 30 minutes. When the product is exposed to higher temperature for a longer time, in the sense the quality and the nutritional properties gets minimized. We can find a loss of quality and nutritional properties of the food. Even though the milk gets, the shelf life gets increased, but we are receiving a less quality product. So that's why the people, they go for a HTST. We are only exposing the milk towards to 15 seconds. And UST, if you are doing all those things in an aseptic condition, the milk can be preserved even for more than 3 months, 6 months. So that is an example of storing the milk in a Tetra packs in a UST preservation in aseptic conditions. So depends upon the type of microorganisms, we can extend the heat thermal preservation technique. For example, if you need to kill a Clostridium botulinum or Clostridium burnetii microorganisms means, so that is a heat resistant microorganisms, so you should go for a higher temperature preservation technique. So that is called as a 12D technique. You are treating the milk towards to a higher temperature of more than 130 degrees Celsius for less than 1 second. So HTST method is also called as a flash pasteurization technique, and as I told, the estimation of the pathogenic microorganisms can be done in the phosphatase inactivation test. And these are some examples of the conventional pasteurization treatments. You can see for the different products of the milk, you can have a different time and temperature combination, so that preserves the milk and also it enhances the shelf life of the product. And effect on foods. Coming to the effect on foods, so pasteurization is a mild heat treatment, minor changes to the nutritional and sensory characteristics. Shelf life, few days or weeks, it depends upon the which type of pasteurization methods you are using. And effect on the color, flavor and aroma. So fruit juices, the main problem is color deterioration. As I told, the polyphenol oxidase is responsible for the color deterioration in the fruit juices. So the pasteurization technique inhibits the enzymes, polyphenol oxidase or any other enzymes that is present in the juice as well as the milk. So the whiteness is as I told, in homogenization process, the uniform distribution of flat globules inside the milk will be taking place. So that changes the color of the milk. So pasteurization does not have an effect on the color. Hence there are some volatile loss of volatile aroma compounds because of when you are treating with a higher temperature. So volatile recovery used to produce high quality juices, etc. Effect of vitamin loss, effect of pasteurization on vitamin loss. So losses of vitamin C and carotenoid are minimized, and changes towards to the milk, 5% loss of serum proteins and small changes to the vitamin content. And these are the examples, vitamin losses during pasteurization of the milk, and the method HTST and the LHT or LTLT. And thank you for the listening. And I think you have a clear cut idea about the processing of the milk as well as the pasteurization techniques and different types of the methods, and how the role of pasteurization have their role on the increasing the shelf life of the product and minimizing the quality losses. Thank you.